welcome to Kubernetes and MLOps for scalable and reproducible generative AI workflows. Nowadays, I think I got it quite okay. Practice makes perfect. But welcome. What will this session be about? So I'm hoping, essentially, because this is a bit of like a, it depends on where you're coming from, what your background is on. Is this a beginner session or intermediate, or even maybe, I don't know, for some people it could be advanced. But my hope is that whatever your background is, you learn more about how does MLOps, AI, generative AI, and all these topics relate to Kubernetes. How do these things work together? So what is kind of the infrastructure behind the generative AI, the large language models, and so forth. So whether your background would be more from the AI side or more from the Kubernetes or cloud native side, I'm hoping that we kind of learn together today what is the match that these two make together. Perfect. Okay, so hi everyone, I'm Annie Talvasto. I'm CMO at Vision, which is a Swiss DevOps company. We have all products as well as professional services and a CNCF sandbox project within our kind of, under our umbrella essentially. So I'm also a CNCF ambassador as well as an Azure MVP, and what those two essentially mean, that I am just super excited about all things cloud native, Kubernetes, and all these things, and I just love sharing about them in events and such as this conferences to everyone who's willing to listen, I guess. I'm also a Kubernetes and CNCF meetup co-organizer since 2017. So a few years now already. I also coach early stage startups via different accelerator programs because that is my background essentially in startup enablement and so forth. And I'm also the co-host of Cloud Gossip podcast. But I always forget to mention something here. So I've also been a track chair for KubeCon plus Cloud Native Con. I've been co-hosting the Cloud Native Live, a CNCF weekly show since 2021 and so forth. So just all things cloud native, I guess, makes me happy, if I can say that. Good. So let's get started. So we have an agenda for today. Let's go. So introduction. We're doing really well. We're already doing that. Then we have some definitions. I think definitions aren't always the most fun part of it, but I think in this topic in particular, definitions are actually quite important to set the scene on what's happening. Then we have why is AI or machine learning different from quote-unquote regular engineering, Kubernetes and MLOps, Kubeflow, best practices, and then some considerations because you do have some that you need to think about when you're doing development within these topics. And wrap up as well as resources in the end. But we want to be having a bit of fun as well. So you see here is a treasure map. As you can see, it's a very like a regular pirate treasure map. You see there's some dangers from the ship to the X, which marks the treasure. And what is the treasure? It's scalable and reproducible generative AI workflows, because that is the goal, obviously, that we want to reach today. So that's why we want to reach. Our treasure is these, and we want to learn, okay, how do they happen? How do we actually empower these? And we have our little robot here that's going to be following the treasure map going along, and we're going to be following that through all the hurdles of the mountains and the sharks and so forth. And what does scalable and reproducible generative AI workflows then look like, or what is the kind of match there? So everyone has heard about ChatGPT, OpenAI, and so forth. These are all essentially products or so forth that are fueled by Kubernetes and MLOps, so that's why we're discussing these things today. Okay, let's get started. Introduction done. We are already on our way. As you can see, our little robot is taking off. So there we go. We moved to the first little jungle. So what is that? That was the definitions part. So what is actually AI? I think everyone kind of has an idea what AI is, but what is it actually? So it refers to the simulation of human intelligence in machines that are programmed to think and learn like humans. So it involves the development of computer systems and algorithms that can perform tasks that typically require human intelligence, such as understanding natural language, recognize patterns, solving complex problems, making decisions, and so forth. Then we move further within our jungle to machine learning. So it is a subfield of artificial intelligence that focuses on the development of algorithms and statistical models that enable computer systems to improve their performance on specific tasks through learning from data. And this is the key, the difference here essentially. It is learning and data is what you can kind of think about, the keywords here compared to the previous one essentially, as well as algorithms obviously and so forth. So moving on to the next tree, data science in itself is the multidisciplinary field that uses various techniques, algorithms, processes, and systems to extract insights and knowledge from data. And actually I have to say that it's quite fascinating that with the boom of AI right now, the hype that's going on, actually job advertisements, for example, or searches for data science or data scientists have actually gone down. Obviously that has kind of switched toward more like machine learning, engineering, and so forth. But it's actually interesting that data science itself as a term might be nothing's going to go fully out of favor, of course, but it might be kind of lessening a bit, and other terms that are a bit more maybe precise and descriptive to the ways that we're doing nowadays might be taking over a bit more. And then key part here is DevOps, so it's short for development and operations. So it's a set of practices and cultural philosophies that aim to improve and streamline collaboration between software development teams and operations. Now, why am I talking about DevOps? Because I think it's important to remember, okay, what is MLOps then? It is machine learning operations, and it's a set of practices, principles, and tools that combine machine learning with practices of DevOps. So if one were to say, like super simplified, you could say that MLOps is DevOps with data. So we can never kind of forget that as the base. There's even a lot of people spoke about having like a Maslow's hierarchy of needs type of structure, where you have machine learning operations, MLOps structure of what are the needs, what you need to master, what you need to do, and DevOps is the foundation of it all. So that's why actually it's critical. Like if you're looking for any of the beginner best practices, DevOps is usually a good place to start. So that's the kind of setting the scene there. So we have learned AI, machine learning, data science, MLOps, AI, and DevOps and so forth. So that's what we're talking about here today. So now our little robot moves further within this treasure map to get to the treasure actually in the end, and we're going to be entering the mountains here to learn why is AI and ML different. So what sets it apart from regular engineering? So AI and ML workloads and all of the development that goes into it is deeply data-centric in nature. I've been talking about data a lot, but you cannot avoid the topic when you're talking about this subject. So the quality and the quantity of the data significantly impacts the performance of the models. So ML and AI engineers need to focus on the data collection, pre-processing, and feature engineering, which are not essential in traditional quote-unquote engineering. So you have to be data-centric and you have to consider your data. If you put bad data in, you get bad data out, or your results and your models will not look good. Another thing, how this is different, is model complexity. So in regular engineering, systems are typically designed and built according to well-established principles and specifications. And in contrast, ML and AI models are really complex, and their behavior is learned from data. So engineers, you really must experiment with various models, architectures, hyperparameters, and training data to really optimize the performance. Then iterative development is really big as well. So because ML and AI model development itself is highly iterative, so engineers can continually experiment, fine-tune models, and retrain to achieve desired outcomes. So traditional engineering might have a bit more linear processes and predictable outcomes. And then scalability is another big one, because when you're talking about the scale that data, for example, itself causes, it's absolutely massive. There can be big traditional engineering scale as well, but from the get-go, usually the AI and ML engineering requires you to focus on this one, because it really requires scalable infrastructure to handle the large data sets. and computational demands. So it might involve distributed computing framework, GPU clusters, and cloud-based resources. Now, people sometimes ask me, can you do this without cloud? Well, I think everything and anything is possible if you want to set your mind into it, and it is possible. There's examples of doing things without, for example, cloud-native resources or cloud-based resources, but it obviously is kind of a question of what is the easy and what is the hard path, and if the hard part is required by you or your organizational needs, then you have to go for it, but it might be a bit of a more rocky road down the road. Monitoring and adaptation is super crucial as well. So ML and AI systems require ongoing monitoring to detect issues like model drift, data quality changes, and shifts in user behavior. So engineers must build systems that can adapt to these changes in real time, which is not necessarily a need in regular engineering. And testing and validation is super important. So in regular engineering, testing and validation can be based on established standards and specifications. It's a bit older, and as I said, it's a bit more linear, so it might be easier to approach there. So in ML and AI engineering, testing often involves evaluating model performance against specific metrics. So it might require domain-specific expertise and may not have a clear-cut pass or fail criteria because it's a bit more complex in that way. Then another thing that people might not have to consider when they're doing regular engineering is explainability and bias. So in the field of ML and AI, understanding why an AI model makes a particular decision is crucial. And this is also obviously due to the ethical considerations, because if you are working in the field of healthcare, finance, or anything that matter, that where your AI or your ML would be making any sort of decisions that involve people, you have to be aware what's happening, and you have to make sure that you understand what is happening within your models. Another thing that sets us apart is rapid advancement. So the field of ML and AI is really evolving fast. I think we have all seen the jumps that we have seen recently in these fields with all the models coming out and people catching up on the developments and so forth. So it is something that really affects the way that people are working on the field. And then interdisciplinary collaboration is a big one as well. I'll talk a bit more about how does the production cycle look like, but you have to really collaborate with different professions within the company or the organization that you're working for, because it requires collaboration between data scientists, software engineers, and domain experts and infrastructure engineers. And now this is, I think, a big one. Anytime I speak about these topics in conferences, like I was speaking about in KubeCon last week, people usually come up to me and say, oh, I have this skill set, how do I learn more about this other side, or how do I interact and so forth. So it's a big kind of learning that we need to take on as a tech industry as well, is to bridge the gaps between all the different professions that are working on these questions. And then deployment challenges is another one. So deploying ML and AI models into production requires special considerations. So you must really ensure that the models are served efficiently and can handle real-time requests and integrate with existing systems. And cost is another big one. Anytime you watch any sort of like people talking about AI, ML, you usually run into the topic of, people are talking about that, okay, we want to do this at scale, we want to actually ingest the data, but we don't want to go bankrupt for it. And I don't think anyone wants to go bankrupt for that, which is actually, it is a consideration within this. And if you look at, for example, the GPU prices and how they are going forth, and I was just going through, for example, needing a GPU for a demo, and pretty much even the cheapest resources are quite expensive at the moment if you need to get them. So it's definitely something that you have to keep in mind with these in particular. Not that cloud cost itself wouldn't be a topic in other engineering fields, but nevertheless. So those are essentially some of the differences with AI and ML compared to regular engineering. So if there is, so these are some of the things that you have to keep in mind that are AI specific. And obviously then when you think about the best practices or how do we help with these is some of the issues that you have to solve. So you have to solve for scale, you have to solve for the collaboration and so forth. So these are also the talking points that people run into within the organization. Now, how does it then look like from research to production? So it obviously requires expertise, knowledge, and time to build an AI model, for sure. But it might, in some cases, only take a few weeks for a engineer to come up with a new AI model or a data scientist. But then actually, when you take it to production, that might be months and months of hard work, because getting to production is actually quite a big bottleneck nowadays. So I think the statistics are like over 70% of models never make it to production, because that is such a hard phase to get over. So it's the hurdle that actually kind of tramples most of the people trying to get the models into production and getting to see the benefits from it. So it definitely is a bit of a work there. And I think it's very telling that last week in KubeCon, for example, the keynotes within KubeCon were actually quite focused on like maybe let's say call to arms for the cloud native scene to help with these bottlenecks, because they are really issues that the industry needs to be solving so that we can get to better place around these resources. So it's definitely something that is important, as I said, to bridge the gap between these professions. So why does it take a long time? Well, it's because of a lot of the reasons what I mentioned in the last slide. So it really goes from, getting something to work on your local machine, as far as things go, that might be relatively, well, I don't never want to say easy, but it might be possible. And then getting it from there to scaling it out, to packaging up, to work on the pattern meters, run scripts, and so forth, to figure out load balancing and data partitions and so forth, to fine tuning and everything, so that everything is built for latency. It all takes a lot of work. And even monitoring and logging, for example, takes a lot of effort than versus like a regular Kubernetes, because in addition to container or Kubernetes monitoring, you have to monitor the data as well. So it's always a bit of an extra consideration. And obviously you need to figure out automation, CI/CD workflows and everything as well. So there's a lot of things that happen there, but it's fine. We can always obviously make it there. So that is some of the kind of considerations. Why do these things differ, and why is this such an important topic to discuss about infrastructure that builds all of these LLMs and machine learning models and so forth? But why Kubernetes then? I've been kind of mentioning it a bit here and there. Why is Kubernetes such a good thing? And then we're going to go, as you can see, nearby the water here. We're moving within our treasure map. So Kubernetes and MLOps, why is it a match made in heaven or so? So Kubernetes itself offers like a really kind of nice, good base layer to build up on top of it. And there's obviously some considerations if you're doing this with vanilla Kubernetes. I'm going to talk about Kubeflow a bit later on. That helps you build up on that pace. But Kubernetes works as a really good kind of infrastructure to use to run your containers in. So portability is one of the reasons why Kubernetes works really well with AI and ML workloads. So Kubernetes really provides a consistent and portable platform for running machine learning workloads. So machine learning models and their dependencies can be containerized using Docker, making them highly portable across different Kubernetes clusters, and you can use even various different cloud providers or on-premises environment, as I said before as well. So you can really develop and test your ML models in one environment and seamlessly deploy them into another, really without worrying about environment and specific issues as well. Customizability is a big one with Kubernetes. So Kubernetes is highly customizable, allowing you to tailor your infrastructure to your specific machine learning needs. So you can configure resources, networking, storage, and security settings to match the requirements of your machine learning workflows. So customization enables the fine-grained control and resource allocation, ensuring that machine learning models receive the appropriate amount of CPU and GPU resources. Performance is a big one as well. So Kubernetes is known for performance. Well, it's built for scale. It's built for massive, container orchestration projects and so forth. And to be honest, if you're asking me, sometimes people ask me, okay, should I be using Kubernetes or when should I not be using Kubernetes? It obviously always depends on your exact requirements and your setup. But quite often, if you have the scale, that might then require the Kubernetes use. If you don't have scale, then you might not be in need of it at all. But as I said, ML and AI itself are very scale focused to begin with, because there's so much data. So that's why Kubernetes is a really good match there as well. So Kubernetes horizontal scaling, for example. Horizontal pod autoscaling allows ML workloads to automatically adapt to varying levels of demand and maintaining effectiveness there as well. And efficient resource management minimizes the resource contention, ensuring that models receive the necessary compute resources to perform optimally as well. Consistency is a big one as well. So Kubernetes enforces consistency by providing standardized and consistent environment for running machine learning workloads. And containers encapsulate the entire application stack, ensuring that the same code and dependency be used for model development and end user are used during the deployment then. So it simplifies the reproducibility of ML experiments and results reducing the risk of discrepancies between development and production environments. And microservice is a big one. So Kubernetes supports microservices, makes it possible that machine learning applications can fit into smaller and independently deployable components, which then really provides modularity and flexibility in ML workflows, making it easier to update and scale individual components without affecting the entire application. And you can build complex ML pipelines by composing and orchestrating microservices as building blocks as well. And composability is the last one on this list of why this works really well nicely together. So Kubernetes allows you to compose and orchestrate ML components and services into end-to-end machine learning workflows. So you really can kind of define, share, and reproduce ML workflows as code, enhancing collaboration and efficiency. Collaboration comes up again because these are all kind of interconnected topics always. So by composing your ML workloads in Kubernetes, you can easily integrate various components like data pre-processing, model training, and model deployment into a cohesive pipeline. So this is why I'm talking about Kubernetes itself. And as I mentioned kind of before, ChatGPT, OpenAI, most of the big models actually, or all the services run Kubernetes, or they even manage Kubernetes services in the background. So that's why that works nicely together. Then we're going to hop even more there. Are we going to go to the school, which is the scary one, I think, or are we going to go somewhere else? Oh, and nope, we're going to go to the next jungle. We're going to talk about Kubeflow, which is the machine learning toolkit for Kubernetes. So how many here has heard about Kubeflow before? 2, 3, 4 hands. Well, that's good. Then hopefully people are going to learn something new. So Kubeflow is an open source platform that's designed to make it easier to deploy, manage, and scale machine learning workloads on Kubernetes. And it provides a set of tools, frameworks, and best practices to streamline the development and deployment of machine learning models in Kubernetes environment. So Kubeflow essentially is designed to work on top of upstream Kubernetes, so you can really easily use it there. So it's a CNCF project, and CNCF it's a CNCF incubating project. So CNCF is a cloud native computing foundation that is Kubernetes' home, for example. So it's fully open source, it's integratable, it goes into this customizable and extensible nature of Kubernetes as well. And there's a host of other CNCF projects that you might want to use for example, for scale, you might want to look into CADA or monitoring the different Prometheus and so forth that are actually providing all the basic building blocks for your DevOps stack for Kubernetes, but Kubeflow in itself is built for machine learning purposes. So how does it then look like and what does it then provide? So it provides that end-to-end machine learning workflow that helps you actually manage these things on top of the Kubernetes. So from data pre-processing and model training to deployment and monitoring, it helps you managing different tools and components separately. So it provides scalability and resource management as well. So it leverages this Kubernetes orchestration capabilities and enables easy scaling of machine learning workloads so that you can dynamically allocate resources based on demand, optimizing hardware utilization and improving performance. It also helps with reproducibility and collaboration, another topic that keeps on coming up. Kubeflow's infrastructure encourages best practices for reproducibility by capturing metadata, environment details, and code versions associated with each experiment. So it really helps you manage from end to end everything so that you can really get the most out of your resources. Even though Kubernetes is a good match, Kubeflow helps with that. So this is how it looks like as well. So Kubeflow includes services to create and manage interactive Jupyter notebooks, for example, so you can customize your notebook deployment on your compute resource to suit your data science needs. You can use TensorFlow model training, you can do model serving, and you can use Kubeflow pipelines to deploy and manage end-to-end machine learning workflows, so you can rapidly reliably do experimentation, and you can schedule and compare runs and examine detailed reports on each run. So there's a lot of that goes into it. And there's actually really good resources as well from Kubeflow itself, where you can see before Kubeflow, this is how your stack would look like. You have all of these phases, from experimental phase to production phase that I was talking about before. But with Kubeflow, you can tap into all of these different resources. So you see PyTorch, TensorFlow, as I mentioned before, pipelines, and all of these things working together with ease within your systems. Now, an example of how this would happening in production and in practice is Shell, who they did a KubeCon keynote a while ago. I think it's 6 months to a year ago in North America 2021 actually. You can see it there. So for them, they have really seen a lot of benefits from using Kubeflow because they had a lot of challenges, and these challenges might sound very familiar at this point in the conversation. So they were challenges where disparate and inconsistent dev environments. So creating proper dev environment was tricky. Local data they could use local data really well, but you can imagine that with the scale of the data with Shell, globally, they needed a new solution. They had a requirement for a lot of different specialized skill sets. And Kubernetes requires a lot of knowledge, and they were also wasting or underusing resources. So for them, cost was a big consideration as well. So Kubeflow helped them solve a lot of these issues with secure cloud hosting and self-service. So rapid onboarding at scale was really important for them, which is a big part of Kubeflow as well. And Kubeflow automated pipelines using Kale as well, and shared cloud resources. So they themselves said, for example, what took them maybe months before, now took them only days or just X amount of the resources. So that was really helpful for them. So you can obviously, for a reason, I've attached the whole name here, but I will have it in the resources as well. But if you want to learn more, you can obviously watch them say these things in their own words as well, as an example of how do these things look like in production. So perfect. We're going to be then moving the best practices here to the mountains again. And obviously, I've been kind of running through a lot of best practices within this session as well already. So this is going to be kind of like a compilation of some of them. So it always starts with data. That's what I said in the presentation as well already. So if the data is wrong, you're not going to get anywhere. You have to also kind of focus on mastering all the necessary skills to do these things, and this goes into the collaboration part of it. So if you are coming from a cloud native background, for example, you might have to focus on learning more data scientist skills, maybe learn to brush up on Python, even math on like statistical math and so forth might be something that you need to look into. But if you're coming more from an AI or ML background, then you might have to focus more on learning about cloud native using CLIs and bash shells and commands and so forth. Know your tools and when you need to use them. So this goes across all of using Kubernetes. So as I said, I just was speaking last week with a person who said that they looked into Kubeflow, and for their scale, it did not make sense at that moment, which is totally fine. Again, all of these things are usually, there's no need to complicate your environments if you are not at the spot where you need them. But if you need them, then you obviously tap into the tooling and use them when you need them. So from Kubeflow to Kata to different solutions that you can add on to really kind of tap into it. And obviously to all the cloud services, cloud companies, cloud computing companies such as like AWS, Azure, Google Cloud, and so forth, and their inbuilt machine learning tooling. So understanding the bottlenecks that you face is super crucial as well. So really focus on these to think about, okay, where do I have to fix and what do I have to focus on? As I said, MLOps loves DevOps, so you really can take a lot of the best practices there. And using tooling like AutoML and Kaizen is important as well. So then we're going to go actually to the school. We don't have a lot of time for the school. I know that we're running out of time, but we have some ethical considerations. I trust that everyone will always focus on these on their own, obviously. So I'm not going to be diving too deep into here, but you really do have to consider fairness and bias. So you must address bias in the data itself and algorithms to ensure fairness. You have to provide transparency so that you can trust and we can understand what's happening within your AI models. You have to focus on privacy, so you have to respect user privacy by protecting sensitive data. You have to focus on accountability, so developers should ensure that AI systems are accountable for their actions. Consent and user empowerment is super important as well, so you should have users should have control over their interactions over AI systems. Security, always important, but particularly for sensitive data and machine learning and AI, it is. Human-centric design as well, so you have to prioritize human well-being and safety when designing AI systems. Data governance is important as well, so developers should establish a responsible data governance practices and long-term consequences. So consider the consequences of these decisions that your models will be making as you go further, as well as regulatory compliance. That's obviously always important. Then here is some links and slides. So these are the Learn More resources. So I have them up. I have the slides already up on my GitHub. And then I think the organizers also gathered the slides, so you can find them from there. If you want to learn more, like, practical hands-on examples, how to get started on this on Azure, Google, or AWS, Practical MLOps by No and Alfredo is a really, really great book that I highly recommend looking into. That includes a lot of practical, well, it's in the name, tips. There's the Shell keynote link there. Then there's some Kubeflow resources, as well as KubeCon has a lot of resources around AI Day and so forth. So there's a lot to learn from there. But that's it. We're starting to be near at the end of the way. We even managed to do the school area with the ethical considerations, because it's a pretty much make it or so far situation. And then we're going to end up here in the treasure, which is great. And here we are. Our little robot is happy. We get the treasure of scalable and reproducible machine learning workflows for Kubernetes. So that is really great. We made it to the end. We can give ourselves a little kind of like tap on the back for making it to there and making it to the end. But thank you from my side. It has been a pleasure. I hope everyone has a great conference today.